am Sreya, MSc Computer Science student, Department of Information Technology, Kannur University. Today, we are going to discuss about the topic reflection in 2D transformation. So, let's start with reflection. Here is an image showing the normal reflection. Reflection gives the mirror image of the object with respect to the axis of reflection. In this figure, we can see that there is an axis between the tree and the river. We can see the reflected image of the tree in the river. Here, the reflection takes place with respect to the axis of reflection between the tree and the river. Reflection is a transformation that produces mirror image of an object. The mirror image for a two-dimensional reflection is generated relative to an axis of reflection by rotating the object 180 degree about the reflection axis. That is, reflection is also a kind of rotation. By rotating the object 180 degree, we get the reflection. Now, let's discuss about various kinds of reflection. Reflection can be classified into four based on axis. Reflection about x-axis, reflection about y-axis, reflection about coordinate origin, and reflection about diagonal line. At first, reflection about x-axis. For reflection about x-axis, what happens is that the x values will remain the same, y values become negative. That is, for reflection about x-axis, no change in x values, change in y values only. Here is the transformation matrix for reflection about x-axis. Transformation matrix can be written as homogeneous coordinate matrix multiplication. The new coordinates can be written as x dash y dash 1 equal to 1 0 0 0 minus 1 0 0 0 1 into x y 1. The new coordinate is represented as x dash equal to x, y dash equal to minus y. That is, there is change in only y value. Y value become negative. Here is the diagram for reflection about x-axis. By observing this diagram for reflection about x-axis, we can see that the x values remain the same. There is only change in y values. The y values become negative. Now, let's discuss about reflection about y-axis. For reflection about y-axis, the y values will remain the same and the x values will be negative in this case. That is, for reflection about y-axis, no change in y values, change in x values only. Here is the transformation matrix for reflection about y-axis. The new coordinates can be represented as x dash y dash 1 equal to minus 1 0 0 0 1 0 0 0 1 into x y 1. The new coordinates can be represented as x dash equal to minus x, y dash equal to y. Here is the figure for reflection about y-axis. By observing this figure, we can see that the only change is that the x values become negative and there is no change in y value. Next, we can discuss about reflection about coordinate origin. For reflection about coordinate origin, the x values and y values become negative. Here is the transformation matrix for reflection about coordinate origin. The new coordinates can be represented as x dash y dash 1 equal to minus 1 0 0 0 minus 1 0 0 0 1 into x y 1. The new coordinates can be represented as x dash equal to minus x, y dash equal to minus y. Here is the figure for reflection about coordinate origin. By observing the figure, we can see that both the x and y values become negative. At last, reflection about diagonal line. For reflection about diagonal line, the x and y values are interchanged. Here is the transformation matrix for reflection about diagonal line. The new coordinates can be represented as x dash y dash 1 equal to 0 1 0 1 0 0 0 0 1 into x y 1. The new coordinates can be represented as x dash equal to y, y dash equal to x. Here is the figure for reflection about diagonal line. By observing the figure, we can see that the values of x and y are interchanged when the object is reflected. Now, let's discuss a problem. Given a triangle with coordinate points A 3 4, B 6 4, C 5 6. Apply the reflection on the x-axis and obtain the new coordinates of the object. Here, from the question, it is given that we want to apply reflection about x-axis. Given all the coordinates of the triangle equal to A of 3, 4, B of 6, 4, C of 5, 6. Reflection has to be taken on the x-axis. First, taking coordinate A of 3, 4, let the new coordinate of the corner A after reflection equal to x new y new. Applying the reflection equation, we have x new equal to x old equal to 3, y new equal to minus y old equal to minus 4. Thus, the new coordinates of the corner after reflection equal to 3 minus 4. For coordinates B of 6, 4, let the new coordinate of corner B after reflection equal to x new y new. Applying the reflection equation, we have x new equal to x old equal to 6, y new equal to minus y old equal to minus 4. Thus, new coordinates of the corner B after reflection equal to 6 minus 4. For coordinate C of 5, 6, let the new coordinate of the corner C after reflection equal to x new y new. Applying the reflection equation, we have x new equal to x old equal to 5, y new equal to minus y old equal to minus 6. Thus, new coordinates of the corner C after reflection equal to 5 minus 6. Thus, new coordinates of the triangle after reflection equal to A of 3 minus 4, B of 6 minus 4, C of 5 minus 6. This is the diagram for reflection of the triangle about x-axis.